Hello everyone, we're going to be covering chapter 5 today. This first section is just the polynomial functions, the basic things about them. As we go, I'll try and get into as much depth as I can. I know I've got a lot of questions over 5.2, so I'm going to get through this one and then show y'all 5.2. So is the expression 4x cubed subtract 3.6x squared subtract the square root of 2 a polynomial? If so, what is its degree? Yes, it's a polynomial, because y is not squared. The degree of this polynomial, your degree is always your highest exponent, so our highest exponent on this one is that 3. You don't add them, so I don't have 3 plus 2, so this one is just going to be that degree is 3. Try not to ramble and make it more confusing than it already is. Okay. If r is a real zero or even multiplicity of a function f, then the graph of f blank the x-axis at r. Okay. First thing, zeros, we call them zeros because that is when x equals 0. That is your x-intercept. So a 0 is where something crosses the x-axis. So this would be our 0. So that would be -3. That would be a 0 there. Now, they're saying that this has an even multiplicity. So real quick, just thinking of our graphs, this one would have been a linear graph because it's a line, right? Which means it would have an odd multiplicity. So since it went across, this one was odd. Now, when we think of even graphs, x squared makes that pretty parabola shape. So this touches. When it's even, it touches. When it's odd, it crosses. Because even if this would have been x cubed, our cubed graph does this. So it crosses at a 0. This one's even, so at the evens, it touches. Remember that evens touch, odds cross, because when we graph these later on, you have to know that. The points at which a graph changes directions from increasing to decreasing or decreasing to increasing are called turning points. So you're turning from increasing to decreasing, so we're going up and then we decrease. You turned. This one, if you're decreasing and then you change to increasing, they're turning points. This might be why I haven't received many questions on it. It's just definitions. The blank of a real 0 is the number of times its corresponding factor occurs. Multiplicity of a real 0 is the number of times its corresponding factor occurs. So I'll wait. I think that'll be easier to understand when we have examples. The graph of y equals 5x to the 6th subtract 3x to the 4th plus 2x subtract 9 has at most how many turning points? So to find turning points, first you have to find the degree. So our degree is the highest exponent on this one would be that 6th power. So our degree is 6. And then to find our turning points, you subtract 1. So 6 subtract 1 equals 5 turning points. And what I want you to think of on this one is, remember, I'll go ahead and mark this, but okay, so when we have y equals x, that's that straight line. There's no turning points because the degree would be 1. 1 subtract 1 is 0. When we have y equals x squared, it's that parabola. 2 subtract 1, 1 turning point. We turned once. Y equals x cubed does this. So it turns here and here. 2 turning points because you take your highest degree and subtract 1. I did all the definitions. Determine whether the following function is a polynomial function. If the function is a polynomial function, state its degree. If it is not, tell why not. Determine whether f of x is a polynomial or not. Select the correct choice below, and if necessary, fill in the answer box to complete your choice. F of x equals 2x plus x to the fifth. Yes, it is a polynomial. It is not a polynomial. It is a polynomial of degree 5. Our highest exponent's 5. They didn't write that one in order. But it is a polynomial with degree 5. Write the polynomial in standard form, then identify the leading term and the constant term. The polynomial in standard form, so this is where we write it in order. X to the fifth, and then it's positive 2x, so plus 2x. And then our leading term is going to be x to the fifth, and we do not have a constant. X to the fifth plus 2x. Our leading term, so whatever is in the front is your leading term. Where's my mouse? So when we put it in standard form, our leading term was this x to the fifth power. And then a constant is something that doesn't have a variable with it. It doesn't have a letter. So ours does not have a constant. So I'm putting 0 in there. Determine whether the following is a polynomial. It is a polynomial. We're not dividing by x or anything like that. So I could break this up right here and write it as negative x squared over 3, and then the 5 is positive plus 5 over 3. So it is a polynomial of degree, our exponent is 2. And then when I write this in standard form, I think I'm going to go ahead and write it like this. We'll see if it takes it. And then this is my leading term. This does not have an x with it. It doesn't have a variable. So that is a constant because it does not have an unknown with it. Does not have a letter. Oh, here we go. Just be sure y'all watch your signs on these. X squared over 3 plus 5 over 3. I wonder if it's going to take it like that. Oh, leading term. Negative x squared. Click out of the exponent over 3. And then my constant is going to be 5/3. One or more of your responses is incorrect. Okay. I want to try right here and put it all over 3. Negative, well, here, let's get our fraction first. So I'm going to have negative x squared plus 5 over 3. Your answer for the leading term and constant are correct, but the answer for standard form is incorrect. Let me see what they want me to put. But your answer for standard form is incorrect. Write the polynomial standard. Begin with the non-zero term. Check of the highest degree and continue with terms in descending order to degree. How did I want it wrote? I got one more thing I can try. Negative x squared over 3 plus 5 over 3. Oh wow. Identify the leading term, select the correct choice below, fill in the answer. So they wanted me to put a 1/3 with it. Okay, whatever. Here. We'll do another one since we know. So it is, the degree is 3 because because that is our highest exponent. Our new one is 8 subtract x cubed. This is one reason I like to do it though, because I need to know how they want me to type it in. So instead of just doing x, they want us to put the 1. So 1/3 x cubed, and then plus, because my 8 is positive, 8/3. And then my leading term right here, which it said this one was okay, but negative 1/3 x cubed and 8/3. Okay, so when you do this one, be sure that you put your 1 with your x, so make your fraction separate from it. That's new. They usually don't like us to do that. Okay. Form a polynomial whose zeros and degrees are given. So when we have a 0 right here, these, we always put them in, is it going to run? Okay. Zeros go in this form, x subtract r, because when we were solving our polynomials before and we'd solve for x, that was telling us that 0, that x-intercept. So each one of these zeros has to go into this form. So I'm going to have x subtract negative 2, x subtract 2, and x subtract 5. Now the degree is how we check these. So since our degree is 3, I have 1, 2, 3 x's. So if I multiplied it all the way out, I'd end up with x cubed. So this is good. Are they going to want us to multiply this out? Here we'd have to simplify this one. We'll try it without multiplying it out. And then if they want us to, I guess we will. Okay. Simplify your answer. Hoping that's just them wanting us to change the subtractive negative to a positive. X plus 2, x minus 2, x minus 5. Yay! So R represents zeros when we're graphing. The reason we don't use Z is because Z represents another plane when graphing. Because there's, you know, right now we have our X and our Y plane. There's another one, and it's the Z plane. All right, so zeros go in here. R is zeros. Our degree is 3. We have 3 different zeros, so that's going to be good. Plug them in. X subtract R, negative 1. X subtract 0. And x subtract 6. So when we simplify these, this one's going to change to x plus 1. Since this one is just going to be x, I'm going to put this x out at front. And then I'm going to have x subtract 6. So there's going to be some of these later on, I believe, that we have to do this in reverse. We have to factor it down to find these zeros. So the stuff we did way back when, we're going to have to remember a little bit. Degree of 4, we have 4 different zeros, so we're going to have x subtract negative 2, x subtract negative 1, x subtract 2, and x subtract 3, and we have degree 4, 1, 2, 3, 4. When I simplify this, we're going to have x plus 2, x plus 1, x minus 2, and x minus 3. I hope. I really haven't got any questions on this one after being sick last week, so I don't think this is the one people were struggling with. The graphing on the next one, I know I received a lot of emails on it. I even got on to do one of them, and they were being very selective on what third point they wanted. So I'm hoping, having it in front of me today, I can try and explain it better. Okay. Zeros, 2 multiplicity 1, negative 3, multiplicity 2. So they've separated it like this on this one because this negative 3 right here has a multiplicity of 2. So our 0 here is 2. And where we put our multiplicity, when we do these, it goes R is 0, M is multiplicity. So I'll go ahead and write it right now. So 1 would go there, but you know we don't raise things to the first power. All the ones before we weren't putting 1 there, so that's not going to stay there. But then how they have it wrote here. So first one is going to be R0, and then the multiplicity is 2. Now it says the degree is 3, so I have 1x, and then there's 2 here, so 1, 2, 3. Then when we simplify this, I'm going to have x subtract 2 times x plus 3 squared. X subtract 2, x plus 3 squared. Something different, something new. Let's see what we got here. Find a polynomial function with the zeros negative 3, 1, and 5, degree 3, whose graph passes through the points 6 and 135. Isn't that 135? Okay. So first, let's set up our polynomial. I'm going to have x subtract negative 3. I'm using my zeros to set this part. X subtract 1 and x subtract 5. So this is going to be x plus 3, x minus 1, and x minus 5. Now that's 6 and 135. So this point right here, I'm trying to think of how, there's, this is y equals right now. They're giving us this point, and we're supposed to see if our graph is being stretched or compressed by a number. So to do that, we have to put in, you know, when we stretch and compress, we're multiplying that function by something. We're multiplying it either by a number greater than 1 or a number less than 1. So there's a value right there in the front that's being multiplied by all of it. Our goal with this 6 and 135 is to determine what this value is. So I simplified our polynomial here, and we're going to plug in our y value and our x value to solve for this a right here. So I'm going to have 135 equals a, and I'm not going to multiply this out to simplify it. I think it's easier to do it like this. So 6 plus 3, 6 minus 1, and 6 minus 5. I don't have a lot of room. I think I'm going to go ahead and go right here though, because it's not going to take up a lot here. 135 equals a, and then 6 plus 3 is going to give us 9. 6 minus 1 is going to give us 5, and 6 subtract 5 is going to give us 1. I'm going to go ahead and multiply these. So 9 times 5 is 45, times 1 is 45. So I have 135 equals, I multiplied these to get 45a. Then I'm going to divide by my 45. And this is going to tell me what a is. How many times does 45 go into 135? 3 times, I think. 3 equals a. Okay. Now when they want us to type this in, they're wanting us to type out in factored form, so that's this. But instead of a, we're going to put 3. Don't put your y equals. Where's my marker? So we're going to type this in, but instead of a here, we're going to do 3. That's ugly, how I wrote over it. And you're not going to type y because we're using function notation. So I have 3 times x plus 3, x minus 1, I did it right. Degree is 3. We have an A. Let's check that answer. Okay. That is all on 5.1. Like I said, I didn't get a lot of questions on this. So let's go hash out the next one. I'm going to stop this.